This video covers the technical, forensic, and organizational aspects of working with Monero, providing a guide for law enforcement and cybersecurity specialists. Why Monero? The landscape of cybercrime is shifting, with criminals migrating from Bitcoin/Ethereum to Monero due to its superior anonymity. Darknet markets supporting Monero are growing, with criminal transactions reaching billions. Cybercriminals realize that using Bitcoin can expose their identities, leading to an increased demand for Monero ransoms. Monero is used across various illicit activities, including darknet markets, ransomware demands, and financing illegal activities. Narcotic platforms and other criminal schemes rely on Monero's anonymity for transactions to evade accountability. Monero's anonymity is a synergy of 4 key mechanisms. These include ring signatures, which hide the real sender; stealth addresses, which generate a unique one-time address for each transaction; ring confidential transactions, or ring CT, which encrypt the transaction amount; and Covry, a system for temporary IP routing to mask the transaction source. Monero utilizes a dual key structure derived from a 25-word mnemonic phrase. Spend keys sign transactions, while view keys are used to scan the blockchain for incoming payments. Addresses can be basic, sub-addresses, or integrated, differing in their prefix and length. From a forensic perspective, analyzing a Monero transaction is like opening a quote black box. The true sender is hidden among others. The receiver is concealed by a stealth address, and the amount is encrypted using ring CT. Without a private view key, traditional chain analysis is impossible. When evidence is not on the blockchain, the investigation shifts to endpoint devices and forensic analysis. The focus moves from complex blockchain analysis to standard digital forensics. Key Monero artifacts can be found in RAM and on the disk. In RAM, look for wallet passphrases, mnemonic seeds, public addresses, and transaction IDs. On the disk, look for wallet files, log files, and paper wallets. Identifying Monero wallets on a suspect's device involves knowing the paths and file names for various wallets like Monero Gwei, Feather Wallet, and My Monero. Also, look out for physical media, hardware wallets, and paper backups of seed phrases. For controlled operations, it's practical to set up StageNet, an exact copy of the main Monero network. This allows for safely practicing asset seizure skills by downloading the Monero Gwei wallet, selecting StageNet mode, connecting to a remote node, and obtaining test XMR from a faucet. Multisig addresses provide the most secure way to store seized assets, requiring signatures from multiple authorized individuals. The process involves key generation, data exchange to create a shared address, transfer of funds, and a requirement for signatures from both investigators to spend the funds. Criminals may use atomic swaps, a decentralized exchange of one cryptocurrency for another, like BTC to XMR, without an exchange. The goal is to quote-quote clean the funds by moving them from a transparent blockchain like Bitcoin to anonymous Monero. Importantly, atomic swaps leave traces on the device, such as client software, configuration files, and logs, which can be investigated. Monero's anonymity is a challenge, not a dead end. The necessary shift is from blockchain analysis to classical investigative actions and digital forensics. Key evidence resides on devices. Focus on seizing and analyzing computers, phones, and storage media for keys, passwords, and seed phrases. Practice in secure environments like StageNet is fundamental for effective seizure procedures. Recommendations include continuous training on new privacy-oriented cryptocurrencies. Develop expertise in forensic software for analyzing memory and disks. Internal protocols for the seizure and storage of virtual assets must be developed and approved. Law enforcement agencies need the knowledge and skills today for effective documentation of unlawful activities.